Hello everyone, welcome back to another tutorial from RoadwayVR channel. My name is Ahmed and I hold a PhD in transportation engineering from York University, Canada. Today I want to talk about autonomous vehicles and the application in SUMO. So we first talk about the fundamentals of the CAV, and then we talk about the simulation tools, different simulation tools, and then developing mixed CAV traffic environment in SUMO, which is a hands-on experience. And then what you can do as a researcher or engineers for your thesis or your projects that you are working. Before going through the tutorials, make sure that you subscribe the channel. And then as you can see, around 90% of the viewers are not subscribed to the channel yet. It will help me a lot. I highly recommend you to check the website roadwayvr.com. It shows all the tutorial at one glance, and each tutorial also provides the direct link to the YouTube, and it's very easy to navigate. Thank you. Okay, let's talk about the AV. As you can see in this image, an AV has different type of sensors like camera, LiDAR, and radar. And these cameras are responsible to detect some objects. For example, the camera is for lane marking detections, traffic signal, road sign. And the LiDAR is responsible to measure the exact distance between a car to another car, for example. And radar is under the adverse conditions. It can play the role as a camera or LiDAR and then help. But the camera is the cheapest one, and then as we go is LiDAR, and radar is very expensive. What an AV sees is in this image. As you can see, the AV see a pedestrian as just a box, yellow box, or other cars as a purple boxes. It changes the environments to the digital lines or the digital perceptions per se. So there are 6 important levels in AV based on the automations. And level 0 is the cars that doesn't have any technology. But as we go forward, level 5 is a full autonomous vehicles, which can basically drive without needing any human interventions. So this is very simple to understand figure that I provided. So level 0 needs steering with hands on the steering, foot on the braking or acceleration, and eyes for monitoring, and also the human interventions. But as we go and move forward, for example, level 1, it only requires, for example, one technology, as you can see here, one intelligent or advanced driving system technology. But level 2, for example, if we have more than one technology, it can control both steering and then the braking, right? So for example, level 1 is just for one of them. If the vehicle has one technology that can handle steering or braking, that's level 1. If it has more than one technology, then that's level 2. And the level 3, if you see the icons are changing to some sort of machine learning or AI icons, which is automated driving systems, now we can call it. And then the difference between the level 3 and 4 and 5 is in level 3, we need some sort of humans interventions. But in level 4 and 5, we don't need the human interventions. Vehicles can go on its own. But level 4 is in the pilot areas right now, but level 5 is a totally and fully autonomous vehicles without needing any interventions. So for example, the Tesla autopilot at, for example, this moment in the year of 2025 is currently considered as a level 2 with all of those technologies. And the Waymo, for example, another company, they are running a very kind of fully autonomous vehicles, but that's considered a level 4 because it's in pilot projects currently. Okay, so what's the difference between AV and then connected vehicles, CV? Left side, the AV has the sensors, the onboard sensors, but CV has the V2V and V2I communications. So CV, the connected vehicles, can communicate with different objects. And then now, if we combine these two, we have the connected autonomous vehicles. Sometimes they call it as a cooperative autonomous vehicle or cooperative connected autonomous vehicles, okay? So it has the both technology on the left image and the right image, which is right image V2V, vehicle to vehicle, and vehicle to infrastructures, the communication, and vehicle to everything, basically, mobiles, cloud, and everything. So the V2X, which is the vehicle to everything, is for it exchange some data like positional data, weather informations between different cars or the infrastructures and cars, right? And using, for example, the DSRC, the Wi-Fi based technology, or 4G or 5G, okay? So the communications then. Okay, so what are the technologies in AV, in autonomous vehicle? The most fundamental and important technology is adaptive cruise control. You will see these keywords a lot in the research and on the industry side. So ACC is making sure for the longitudinal movements of the car that the AV keep a safe distance to the front car or leading car. And then there is another technology for the lane change assistant for lateral movement, which we call the auto lane change or lane change assistant. But for the connected or CAV vehicles, we have now cooperative adaptive cruise control, CACC, which means that it contains all of these things in this slide, the technology, plus the V2V and V2I technology, which is those that we have already talked, communication between the different objects. Okay,